Hello, my name is Gabrielle Rush, and this is my Lab 3 report. So, in this lab, the first thing I was asking myself is, what are we exploring in this lab? And so I was seeing common themes. Introduction was talking about the magnetic field of permanent dipole of magnets, and specifically looking at Biot-Savart's law. And so online, I found this equation that I think has really encapsulated a lot about what we've been learning in our lectures and in our problem sets, and then relating it back to this specific lab. And so I've put that here. And so this is kind of giving us an introduction to the setup for this lab. Um, and here we're looking for the magnetic field calculation. And so the formula that we were given is pretty simple right here. We're looking at B is equal to K R to the N. And so the actual setup for this lab, what we are seeing is that there's a specific east to west axis orientation with a magnet, a very strong magnet we were given on the end. And what we're looking for here is the changes in the magnetic field at certain points that were specified by the lab, and looking both at the changes in the magnetic field of the x and y axis. So I thought that was interesting that it was separating those two specifically for this. And we didn't really dive as much into the z axis because it was on just a flat surface, but so that's kind of the setup before we get into the actual experiment that I performed. So what we were given here in the lab is these 4 steps. As I was kind of mentioning earlier, there's a big importance on the orientation of the x versus y axis. And so what we're doing here is calculating a specific magnetic field value, looking for a magnetic field value, and looking for also the distance between the magnet and the phone at that specific value. So what we were asked to find was an R to the 1,000 value, or R of 1,000 value. They were calling it like R 1,000. And so from that, we were actually able to find at what specific X and Y location we were getting the values that were asked to perform in the experiment. And once you found those values, it was important to actually put a piece of tape specifically at that orientation, sliding your phone up or down, and then side to side to get the actual orientation here. And then once you have the two, you kind of get a cross right there, and kind of X marks the spot, which is where the point that they were specifically asking us to find. So this is my experimental version, and so it's a little bit difficult to see because I'm using clear tape. But nonetheless, I have this tape measure, which is also another piece of tape, incremented in centimeters. My magnet, a little bit difficult to see here, is oriented. This is east to west. And I have my phone here. This was my specific X marks the spot from my experimental values. And it looks very similar to the lab setup. So I was pleased to see that it looked very similar to that. And so the app I used was a physics toolbar. And I was looking for specifically, it says like X equals 1002.947. And this value is going to come up later in this experiment. But what this helped me visualize was the actual difference between the coordinates. So I thought this was a great app for me. It even has like the time and the magnetic total. And so from these values that I captured here are going to be shown later in the lab, and that's what I was recording for my magnetic field values. But going more into some of the calculations that we were asked to perform, the N value calculation, so the formula I mentioned earlier with Biot-Savart's law, this is trying to calculate just our N value here based off of our R, which is the distance between the magnet and the phone, and our actual magnetic field values that we were capturing through our app. So from this, I was able to derive and find that my N value was 4.51. My GlowScript code is written right here, and going through this, following the procedural steps that were given to us in this lab, I was able to plug in my specific R value, my R average value, and then outputting, I was able to find a 45-degree angle. And so this was a different part of the experiment. We were also asked to turn our phone at 45 degrees and find the magnetic field and kind of compare it to our values that we've captured from this code. So in this code, I was able to, here's my visual representation here of the magnetic field. I printed a lot of statements, just I wanted to see how everything was going as I was going along. And so from there, moving on in my Excel sheet, I have my calculations of my R values. These were actually recorded, and then I was multiplying them down, my magnetic field values that were recorded, and then continuing down in this incremented fashion, I was able to plot this, and this is comparing the ln of R versus the ln of B, and it actually, for me, I got a fairly linear graph, which I thought was very interesting. And so moving forward, as I was talking about earlier, with the 45-degree change, there was a difference in my magnetic field value. And so from my code, I calculated that my magnitude of my magnetic field would be 1011.1 newtons per coulomb. And as you can see written right here, I have my experimental value being 1002.947 newtons per coulomb. And I think this is really important. And I noticed that my two values were actually very similar to each other, which kind of goes to show that I think that the code is a pretty reliable source for the calculation of it. And everything that we have set up seems to be working that way. And so these were my values here for the magnitude, and my R value, I had it at a little bit over 3 centimeters, I believe was my average for that. And in conclusion of everything, I just wanted to go over that this is kind of tying everything in together about magnetic field. We're bringing in Biot-Savart's law. We're manipulating equations and formulas to be able to calculate things. And I think it's really great that we were able to do this with an app, and it really shows, just based off of the orientation, how much everything can change. I was so shocked when I was like moving my phone just a little bit, how much there can be such a drastic change in the magnetic field in one or more of the axes. So I think all of that said, this is the end of my experiment. Thank you so much.